In today's notes, we're going to talk about Cramer's rule. And Cramer's rule is just another way in order to solve a system of equations. What we could do is we could solve for each variable that we want separately. So I could just say, let's solve for x. I could say, let's solve for y, or for z, and so forth. So let me show you how it works with this example. Here's my system of equations. These a's in front with these subscripts, so a sub 1, 1, a sub 1, 2, a sub 1, 3, and so forth, those are your coefficients. The subscripts represent what row and what column. So this sub 1, 1 means first row, first column. Here's the first row, second column. This is the coefficient of the first row, third column, and so forth. So if we set up to solve for y, the denominator is always the coefficient matrix. So I'm going to do the coefficient matrix, which would be a sub 1, 1, a sub 1, 2, a sub 1, 3, a sub 2, 1, a sub 2, 2, a sub 2, 3. Oops. And then the bottom one is a sub 3, 1, a sub 3, 2, and a sub 3, 3. Now on the top, what I'm doing is I'm basically keeping those coefficients, but I'm making one change. So if I look at, these are all my coefficients underlined here in red, and that's what's in the denominator. If I'm going to solve for y, what I'm going to do is I'm going to take these constants on the right-hand side, and I'm going to replace them with the coefficients that are in the y section. If I were to solve for x, I'd replace them with x. So what that's going to look like is this first column and this last column, they're going to stay the same. Here's my x column, here's my z column. Those all stay the same in here. So we have a sub 1, 1, a sub 2, 1. This is a sub 3, 1. And this one stays the same too. A sub 1, 3, a sub 2, 3, a sub 3, 3. And then what's going to happen in that middle row where the y's normally are, I'm replacing that with our constants. So that's b sub 1, b sub 2, and b sub 3. And what we're going to do in example 1 is we'll go ahead and use this process to find our solutions. So example 1 says, use Cramer's rule to find the solution to the system of linear equations if a unique solution exists. So if I set up this 2 by 2 and I want to find x, we're going to say x equals, now the bottom is our determinant of our coefficients, so 3, 2, -4, and -1. And then remember when we do the top, if I'm solving for x, that means my constants over here need to replace the x's. So up on the top here, instead of having the 3 and the -4, I'm going to put in the 6 and the -13. And then the y's stay the same as 2 and -1. And what I'm doing is I'm just finding that determinant. So to find the determinant of the top, I'm taking 6 times -1, which is -6, minus, then I'm taking -13 times 2, which is -26. So I'm subtracting a negative, which will make that a positive 26. And then on the denominator, I'm going to take 3 times -1, which is -3, minus -4 times 2, which is -8. And if I subtract a negative, that's going to become a positive 8. So I get -6 plus 26, which is 20, divided by 5, which is 4. So I know that x is equal to 4 in this system. Then if I want to find y, move this up a little bit. If I go to find y, now what I want to do, my denominator is going to stay the same. So where my denominator is that coefficient matrix, well, I know that denominator is going to be 5. I don't have to refine that determinant all over again. So I'm just going to carry that 5 down. But my top is what's going to change. So where before I had plugged in for the x's, so this replaced the x, now that I'm solving for y, these numbers right here are going to replace the y. So it has 3 negative 4, and now that 6 and negative 13 go in the y column. And if I calculate that determinant, 3 times negative 13 is going to be negative 39, minus, here I have negative 4 times 6, which is negative 24. So if I subtract a negative, that becomes a positive 24, and remember this is still over 5. So negative 39 plus 24 will give me negative 15, divided by 5, or negative 3. So I can say that my solution to this problem is x equals 4 and y equals negative 3. If you have any questions, please let me know.